Hello students, so welcome you all. In today's lecture we are going to discuss some special biquadratic equations which can be solved using the concept of quadratic equations and some miscellaneous and previous year questions of Olympiad, IOQM or RMO. First we will see some special biquadratic equations. First in this category is, suppose we are given this type of a biquadratic equation in which sum of two coefficients a plus b is equal to sum of other two coefficients c plus d. So what we can do, we can multiply these two and multiply these two. Now a plus b is equal to c plus d. So consider this as t and the equation will become t plus ab, t plus cd equal to e. That will be a quadratic equation which can be solved using the quadratic formula, the value of t, then we can also find the value of x. Let's take an example. X minus 1, x minus 2, x minus 4, x minus 5. Okay. In this we can see that 1 plus 5 is equal to 2 plus 4, a plus b equal to c plus d. So we can multiply x minus 1, x minus 5 and x minus 2, x minus 4. This will become x square minus 6x plus 5 and this will become x square minus 6x plus 8. Now consider x square minus 6x as t. So the quadratic will become, the equation will become a quadratic and this will be there will be two values, either t equal to 0 or t is equal to minus 13. So x square minus 6x is equal to 0 or x square minus 6x is equal to minus 13. So we needed to find the value of x. Two values are 0 and 6. And for other two values we can see that the discriminant of this quadratic equation is negative. So both the roots will be non-real. Three plus minus 2i. So we are getting 4 roots, out of which 2 are real and 2 are non-real, and as we have already seen, the non-real root are occurring in pairs. Next in this special biquadratic category is, we are given the equation as x minus a, x minus b, x minus c, x minus d, again the product of 4 linear factors, is equal to some constant into x square. And here the condition is, we can see here in this, if AB is equal to CD. If AB is equal to CD, then again we will multiply A and B factor and C and D factor. Now as we can see, if AB is equal to CD, and we will divide this equation by x square, upon x square. I am separating 2x like this, so this will become x plus AB by x minus A plus B, and x plus CD by x minus C plus D. See now, x plus CD by x and x plus AB by x both are same, as we are given that AB is equal to CD. So consider this as T, and this will become a quadratic equation in T, which can further be solved using quadratic formula. After getting T, we can also find the value of x. Let's take another example in this case. Okay. So in this equation, we have to check which condition is happening. A plus D is the sum of two coefficients equal to sum of other two coefficients? No. Then we will go for the product, and here this is x square, so we will go for the product. So we can see that 2 and 6, product of 2 and 6 is 12, and product of 3 and 4 is also 12. So what we will do, we will multiply these two terms. And also we will divide the equation by x square. Now separating the x square in these two, the equation will become x plus 12 by x minus 8 and x plus 12 by 8 minus 7. Now let x plus 12 by x as t. So the original equation will become a quadratic in t, which we can solve (26), 13 and 2. Now t was x plus 12 by x, so x square minus 13x plus 12. The value of x is 1 and 12 from this equation. Again, discriminant is less than 0, we will be getting two non-real roots. So x minus 1 equal to plus minus root 11i, 1 plus root 11i, 1 plus 1 minus root 11i. So again we are getting two real roots and two non-real roots. So if you are seeing these type of pattern in a biquadratic equation, you can apply the conditions. Next, one more type is there. If in a biquadratic equation the coefficients are like this, the coefficient of x power 4 and constant are same, the coefficient of x cube and coefficient of x are same, and coefficient of x square can be anything. In these type of quadratic equation, there is a concept, there is a working rule by which we can solve this. We can also convert this as a quadratic equation. What we will do, we will divide this equation by x square. So the equation will become like this. Now the same coefficient terms we will collect. So this will be a quadratic. Write x square plus 1 upon x square as x plus 1 upon x whole square minus 2. Now we can consider x plus 1 upon x as t, and this will become a quadratic in t. So we can take an example on this. See, in this equation, this is a biquadratic equation and coefficient from beginning and end terms. The coefficient of x, leading coefficient is equal to the constant coefficient. The coefficient of x cube is equal to the coefficient of x, and coefficient of x square can be any number. So dividing this equation by x square yields so this equation will become x plus 1 upon x, x plus 1 upon x minus 2. So x plus 1 upon x is 0 or 2. From this both the roots are equal, 1 1, and from this both the roots are plus minus root minus 1, which is I. Okay, so these are three different types of biquadratic equation where we can use the concept. If coefficient sum is constant, if product of coefficients is same, and this type. Okay, one more is there, but that is quite straightforward. If you are given this type of quadratic in which no x and x cube coefficient is there, you can simply consider x square equal to t, and this will become a quadratic equation. Let x square equal to t. So in this case there are all four real roots. So this was different types of biquadratic equation which can be converted in quadratic by substituting various values, various terms in x as t. Okay, one problem of biquadratic equation we can do, which is of the miscellaneous type. A biquadratic equation is given Okay. In this biquadratic equation, we are given that the product of the two of the four roots is 35. We have to find the value of b. The product of two of the four roots. The given biquadratic will have four roots, and we are given the product of two of the roots is 35, and we need to find the value of b. So simply we need to find all the roots. Okay. Let the roots are alpha, beta, gamma, delta. So the product of two of the roots is 35. Product of other two roots is 143. Now we are not given the sum of the roots. Sum of the roots alpha plus beta plus gamma plus delta is 36. Alpha, beta, gamma, delta. From theory of equation, the sum of product of the roots taken two at a time is 2556. We need to find alpha beta plus beta gamma plus gamma delta plus alpha gamma plus alpha delta plus beta delta, which is equal to b. Now see, the product of two of the roots is 35 and product of two of the roots is 143. So I can factorize this biquadratic in two quadratic factors like this: x square minus ax plus 35 and x square minus bx plus 143, where a will be equal to alpha plus beta and b will be equal to gamma plus delta. Okay. Now from this identity we can compare the coefficients and find the relation between a, b and capital B. Multiplying the right, or either comparing the coefficient. Comparing the coefficient, we are getting, if we are equating the coefficient of x cube, 36 will be equal to a plus b. 36 will be equal to, which we already know that sum of the roots is alpha plus beta plus gamma plus delta. Now comparing the coefficient of x square, we get b is equal to, the coefficient of x square will be 143 plus 35 plus ab, 143 plus ab plus 35. So b will be equal to 178 plus ab. Now coefficient of x, coefficient of x will be 2556 minus of 2556. From here it will be minus 143a minus 143a minus 35b minus 143a minus 35b. That's it. So this is our third equation, and the constant term 5005 is equal to 35 into 143, which we have written already. Now solving these two equations will get the value of a and b, and we will be able to find the value of b. Let's do it. A plus b equal to 36. This is plus. Okay. 143a plus 35b is equal to 2556. Solve. The factors are 11 and 13. 7 and 5 prime factors. We will have to multiply this equation by 35 and subtract. So 143 minus 35a is equal to 2556 minus 35 into 36. So this is 3 into 6 into 6 into 36. This is 6 into 6 into 66. So this equation is 36 into 66. (108a) is equal to 36 into 66 minus 35, 31. So a is equal to 31 by 3. Similarly, we can find the value of b. A is 31 by 3, b is equal to 36 minus 31 by 3. 75 by 3, 15. B is 15. How is it possible? Okay. 77 by 3. Okay. B is equal to 77 by 3. A is equal to 31 by 3. Think there is some miscalculation. These two equations are same. We have multiplied this equation by 35 and subtracted. So 2556 minus 35 into 36. This is the value of A and B are should be integers. So only the calculation part remains. 2556. 2556 is 6 into 6 into 6 into 72. Sorry. 6 into 6 into 71. 36 into 71 minus 36 into 35. So this will become 36 into 36. 36 into 36. So the value of A will become 12, and by putting this in equation, B will be 24. So capital B is 178 plus 12 into 24. That was some calculative question. 288. And the sum is the value of capital B is 143 plus 35 plus AB. The value of AB is 12 into 24. This is 466. Okay. 143, 178. 143 plus 35. Okay. Now, let's take some previous year questions of quadratic equation. Integers A, B, C satisfy and A square plus B square minus C square equal to 1 minus 1. What is the sum of all possible values of A square plus B square plus C square? Okay, so we are given two equations and three unknowns ABC are there, and again one more condition is given that ABC are integers. So we need to use the two equations A plus B minus C equal to 1 and A square plus B square minus C square equal to minus 1. How can we use these two conditions simultaneously? We need to find an expression in the square of A, B and C like this: A square plus B square minus C square. If I square now, then I will get the expression A square plus B square plus C square. So what we will do, we will take C there, and now we'll square this equation. A square plus B square plus 2AB is equal to 1 plus C square plus 2C. Now A square plus B square minus C square will be equal to 1 plus 2C minus 2AB. Okay, 1 plus 2C minus 2AB. Now A square plus B square minus C square is minus 1. So minus 1 is equal to 1 plus 2C minus 2AB. So the equation becomes 2 plus 2C minus 2AB. Again we are stuck with an equation with three variables in it. Now we can use this: 1 plus C is equal to A plus B, eliminate one of the variables. So A plus B minus AB equal to 0. Now this equation can easily be converted into two factors. How come? Take B common, 1 minus A plus A minus 1 plus 1. Now we are taking factors A minus 1 common, so minus B plus 1 will be equal to minus 1. So A minus 1, B minus 1 equal to 1. Now the product of two integers is 1, which can only be possible when both of them are 1 or both of them are minus 1. So A minus 1 and B minus 1, or A minus 1 minus 1, B minus 1 minus 1. Here A is equal to 2 and B is equal to 2, and for A equal to B equal to 2, C will be equal to 3. Here A equal to 0 and B equal to 0, If A and B are equal to 0, then C will be equal to minus 1. Now we are asked sum of all possible values of A square plus B square plus C square. So A square plus B square plus C square in this case is 4 plus 4 plus 9, that is 17, and this case is 0 plus 0 plus 1. So the sum of these two values is 18. So answer to our problem is 18. Okay. So the problem solving attitude is important in these type of problems. How we can convert these two equation in a single equation having two factors whose product can only be an integer when both of them are 1 or both of them are minus 1. Let's take another previous year question. Suppose an integer x, a natural number n, and a prime number p satisfy the equation. The equation is 7x square minus 44x plus 12 is equal to p power n, and we are asked the largest value of p. Okay, so this is a previous year question of IOQM, and clearly this will be categorized in the topic quadratic equation. Now the problem solving part is important. We are given a quadratic equation in which another thing is p to the power n. P is a prime number, n is a natural number. We have to find the largest value of p. See, the quadratic part is, we can first needed to observe, we need to observe first that this factor, this quadratic expression can be factorized or not. So 7 into 12, 84, 44 can be written 42 plus 2. So this can be factorized. X minus 6, 7x minus 2. Okay. Yes. So the product of two numbers, x is an integer, so the product of these two numbers is a prime factor, prime, p to the power n. So both of these expression I can say are the their prime factor is 5, their prime factor is p, but their product can be anything. See, now we can write both of these numbers, x minus 6 and x minus 7x minus 2 are prime numbers. No, but product of two prime numbers, this is not necessarily a prime number, na? The product of two numbers is p to the power n, but it is not a prime number. So how we can write this equation? 7x minus 2, see, two factors are 7x minus 2 and x minus 6. Product of both of them is equal to a integral power of, natural power of a prime number. If I can write the linear combination of these two, that will be a factor of p. See, I can write by eliminating x, 7x minus 2 minus 7 times x minus 6 will be 40, 42 minus 2, 40. Okay, so this is of the form p to the power alpha, as the product of these two is p to the power and p is a prime number. This will be a this will be of the form p to the power alpha. This will be of the form p to the power beta. So we can write p power alpha minus 7 into p power beta is equal to 40. And the prime factors of 40 are 2 and 5. Prime factors of 40 are 2 and 5. So now from this we need to find the maximum value of p, largest value of p. Now we have to find the alpha and beta satisfying these two equations. P can either be 2 or 5. If p is equal to 2, so this will be 2 power alpha minus 7 2 power beta is equal to 40. Now alpha minus beta, beta can be now we will have to consider the values. If p is equal to 5, this will become 5 power alpha minus 7 into 5 power beta is equal to 40. Maximum value of prime number. See, for largest value of p, for largest value of p, if one of them does not have any factor of p, then it can have largest value. See, from here, if I take beta, 2 power alpha is equal to 40 plus 7 into 2 power beta. We can put the values of beta. If we put beta equal to 0, this will become 2 power alpha is equal to 47. 5 power alpha is equal to 47. Beta equal to 1, 2 power alpha will become. So in this question, let me check the question first. If we take p 2 or 5, then the value will be like this. If beta is equal to, let's say, 3, 2 power alpha will be this 96, not possible. Beta equal to 1, not possible. 2, not possible. In p equal to 5 also, beta 1, at beta equal to 1, this will become 75. What if beta is 0? We have to find the maximum value of p, na? If beta is equal to 0, p power alpha is 40 plus 7. This is 47. So p is equal to 47, alpha is equal to 1. This is the largest prime number. P is equal to 47. See, by considering 40 as 2 power 3 into 5, we are stuck with p equal to 2 and p equal to 5. I am not getting any integers. So rather if we put beta is equal to 0, then p power alpha is a prime number itself. So p, maximum value of p will be 47. Let's take another problem. Let px is equal to a0 plus a1x plus a2x square an x to the power n be a polynomial in which ai is a non-negative integer. For each I belongs to 0, 1, 2 to n. If p1 is equal to 4 and p5 is equal to 136, find p3. So we are given the value of p1 and p4, 5, and all the coefficients are non-negative integers. Okay, all the coefficients are non-negative integers. So p5 is 136. What will be the p5? a0 plus 5a1 plus 5 square a2 plus 5 cube a3 plus 5 power 4 a4. See, a1, a0, a2, a3, a4 all are non-negative values. So if p5 is equal to 36, we can say that this term cannot be possible. This term is not possible. So we can say that n will be less than or equal to 3. The degree of this polynomial will be either 3 or 2. So we can check for degree 1. If we take polynomial of degree 1, then p1 equal to 4 and p5 equal to 136. So a will be equal to 33 and b will be equal to 4 minus 33. Not possible. The value of b is coming out to be negative. So linear is not possible. Let's go for quadratic. We have established that the degree of this polynomial can be less than or equal to 3. Okay. Now we have also established the degree cannot be 1. Now for n equal to 2, a1x plus a2x square. Now p1 is equal to 4 and p5 is equal to 136. 5a1 plus 125 a2. Sorry, 25 a2. 25 into a2 plus 5a1 plus a0 is equal to given as 136 and p1 a0 plus a1 plus a2 is equal to 4. The maximum value of a2 can be 4. The maximum value of a2 can be 4. If I put a2 equal to 4, this will become 100. Then a0 a1 will be equal to 0. See, this term can reach to a number 136 when this is maximum. For a2 to be maximum, it can be equal to 4. Maximum value of a2 is 4. In this case, a0 plus a1 will be equal to 0. Okay. So for a0 a1 equal to 0, so I can say that this expression is less than or equal to 100. But we are given that value of p5 is 136. Okay, so n cannot be equal to 2, n cannot be equal to 1. So the only possibility is n is equal to 3. The polynomial is a cubic polynomial. Now P1 equal to 4. This is equal to 4, and P5 5A1, 25A2, 125A3 is equal to 136. A3 cannot be 0 because it is a 3-degree polynomial. So A3 either can be equal to 1 or 2, but if we put A3 equal to 2, this will become 250 and the coefficient will be negative. A0, A1, A2 will be negative. So A3 can be 1. If A3 is equal to 1, 125 plus 25 will become more than 136. So A0, A1 will be negative. So A2 will be 0. If A3 is equal to 1, A2 will be equal to 0. So now A0 plus 5A1 will be equal to 136 minus 25, 11, and A3 1, A2 0, A0 plus A1 will be equal to 3. Now solving these two, A1 is equal to 2. For A1 is equal to 2, A0 is equal to 1 and A3 equal to 1. So the cubic equation will be x cube plus 2x plus 1. For this cubic equation, we are getting P1 is equal to 4 and P5 is equal to 136, 125 plus 10 plus 1. Now we have to find the value of P3, that will be equal to 34. See, in the questions asked in the IOQM or RMO, the problem solving is important. This was also a question of theory of equation n degree polynomial, but we needed to establish that the degree, first the degree of the polynomial, then the coefficients of the polynomial. If we have found that, then we can easily find the value of P3. So let's conclude our lectures. The quadratic equation is complete. Hopefully this will be helpful for your exams, for your competitive exams in IOQM or other Olympiad exams. All the best. Thank you.